We're going to take a look at the common measures of spread. That is standard deviation, the interquartile range, and the range, and how each of them can be used a little bit differently. Here we have two lists of numbers, two distributions, and what I want to do is punch each of them into the calculator. Pull up our stat edit menu, and we're going to type in each of these lists, and we're going to try to see which of them has a wider spread. So we have 5 2s in here, and then a 3 at the end. And so let's go ahead and do our one variable statistics and get some data on this. Alright, we have a mean of 2. We have a standard deviation of 0.58 if we round that off. So let's go ahead and write that in. We'll call that 5.8 for the standard deviation. And then the interquartile range, I could scroll down and look at my 5-number summary, but I know that with a distribution like this, if this is the median, this is quarter 1 and this is quarter 3, so I would just simply subtract 2 minus 2, so my IQR is actually 0. And then my range is my highest minus my lowest, so I can just look at the numbers again for that and see that 3 minus 1 is going to be 2. On the other side here, this one looks a little bit more difficult to figure out, so let's go back to our stat edit, go up, clear our numbers, and punch in the new distribution. So we have a -3, -1, oh, I'll fix that. So we punch in each of these numbers in our stat list. We then go to stat, calc, one of our stats, and we get this data here to work with. Now, again, our mean is 2, which is the same as this one, so we're dealing with two things that have the same mean, same center, but it looks like the standard deviation for this one, Sx, is a little bit higher, 3.42 if we round up. 3.42. Interquartile range, I'm going to do it the same way I did over here instead of looking at my 5-number summary. This is my median, this is my quarter 1, this is my quarter 3. 5 minus a -1 is going to be 6. And then my range is going to be the highest minus the lowest. 7 minus a -3 is going to be 10. So looking at these two distributions here, it seems that this one on the right is more spread out in every measure. Has a higher standard deviation, higher interquartile range, and higher range. Given that the numbers are literally farther apart from one another, most of these are clumped up all next to each other, most of these are very spread out, it makes sense that the spread is higher for this distribution. So that's what it means to have a higher spread, is the numbers are, on average, farther apart from each other. Now let's compare the distribution we started with in the orange before to a slightly different distribution. You can see that they both go from 1 to 3, but the numbers in the middle and this one are a lot more clumped up around 2, and here they're a little bit more spread out to the ends. So what I would expect is, it seems like, since they're not all clumped up towards the center, that this one's going to have the higher measure of spread. So let's calculate each of them. Go to our stat edit again. You're going to love this function. Clear that list, punch in each of the numbers. When your list is punched in, go to stat, calc, one of our stats. Make sure I did that right. And then we have our data here. So our standard deviation is 1. So on average, numbers are 1 away from the mean. Let's write that in. Interquartile range, we can figure that out the way we did earlier. That's my quarter 1, that's my quarter 3. 3 minus 1 is going to be 2. And then range, highest minus lowest, 3 minus 1 is 2. So that initial prediction that the measures of spread are going to be higher with this one than they were with the orange distribution is true for the standard deviation. It's a little bit higher. Interquartile range was 0 before. Now we do have a range, so that's good. But our actual range itself did not change. Now the reason is because the first and last number are still the same. They're equally far apart. They're 2 apart. So your range is only 2. However, within that, in the middle of the distribution, some of the data is more spread out here than it is here. So when you're looking at measures of spread, you want to consider all three of these numbers because they can tell you different things. One thing to also remember is that the standard deviation is how far away things are from the mean. I'll write that here, from the mean. The reason that that's important is because if you have outliers in your distribution, then that mean might be something really goofy, and so outliers can make the standard deviation a little bit goofy. So both of the distributions that we looked at so far, neither of them have any particularly large outliers, so the standard deviation worked pretty well. If you threw in a 10,000 in this distribution, both the range and standard deviation could be pretty affected by that, whereas the interquartile range kind of buffers out those things really, really far off in either direction as outliers. So if you're looking for something resistant to outliers, interquartile range is your winner. Otherwise, standard deviation and range are useful information. For the more visual in the crowd, here's another way of thinking about standard deviation. Imagine you have a histogram, or you could consider this like a bar graph, and you have values that are, there's a 3, a couple 4s, a few 5s, 6s, and 7s, and then same thing over here. If you wanted to plot the mean's going to be somewhere near the center of all this, perhaps a little bit on the higher end here. 5 point something, let's say. And then over here, same thing, maybe a little bit on the lower end of 5. So I just sketched in the mean. But the way that you measure standard deviation is on average, how far are each of these blocks from the middle? So we have a gap this big, gap this big, gap this big, and then some smaller ones here. This one's very close. This 5 block is very close to the mean. Here, here. And what I'm doing is I'm drawing the distance from each block to that center mean green line. Over here, if you notice, most of the lines are actually pretty short. Most things are fairly close to the mean. So a lot of the data is clumped up around the mean. Now the reason that this is important is however long these purple lines are on average is roughly what your standard deviation is. So most of these purple lines are a little bit shorter, so this one is going to have a smaller standard deviation. Whereas the one on the right, because the purple lines are kind of long, because most data points are far away from the middle, it's going to have the higher standard deviation. And that's what happened here. Most of these data points are clumped up on the left and right, so they're farther away, higher standard deviation. Here most of the data is in the middle, lower standard deviation. So that is the different measures of spread.